So this truck can charge at 1.2 megawatts.
Right.
And so we can recover about 60% in 30 minutes.
Wow,
So
30 minutes.
2 years ago, Jay Leno got to experience the Tesla Semi and even pulled one Tesla Semi with another. That meant the truck was able to tow over 20,000 pounds without any issues. Even more interesting, it uses an automatic regenerative braking system to store and recover energy, which makes everything, including braking, feel smoother, even when braking. Jay Leno said it didn't feel like he was pulling a heavy load behind him. Based on the overall experience, he believed this truck could mark the beginning of a revolution, and that video racked up 3.3 million views. When the refreshed version of the Tesla Semi was unveiled, Jay Leno once again got behind the wheel to test and review the truck before it goes into mass production. The upgrades, improvements, and added features were revealed in great detail, including a new battery capable of lasting up to 1 million miles. Now, let's take a look at what the improved 2026 version has changed compared to the prototype from 2 years ago. Yeah, Jay Leno was the first person outside of Tesla to sit behind the wheel of the new production version of the Tesla Semi. Just like last time. This test drive also featured Franz von Holzhausen, Tesla's chief designer, and Dan Priestley, head of the Semi program. First of all, thanks to Jay Leno, we learned that the new Tesla Semi has cut out 1,000 pounds compared to the previous generation.
we cut about 1,000 pounds out of the truck. And this long-range truck, the 500-mile version, is about on par.
Okay. We've learned that this weight reduction isn't just a simple number. It's the result of a fully optimized chassis design, the use of advanced composite materials, and smarter battery integration. In the traditional trucking industry, every extra pound increases fuel consumption and reduces payload capacity. With the Semi cutting 1,000 pounds, about 453 kilograms, makes the truck more agile in operation, especially on hilly terrain or long highway routes. Looking deeper, this reduction allows the Semi to reach a full gross vehicle weight of 82,000 pounds, the standard for diesel trucks, without sacrificing range. This becomes even more significant when combined with the 2,000-pound exemption granted to electric vehicles in certain U.S. states, making the Semi a direct competitor to diesel trucks in terms of real-world hauling capability.
From the last time we saw you, it's a 7% improvement on the aero efficiency from before, so it's the CD is about 0.4.
Next is a 7% improvement in aerodynamic efficiency. This is a major leap compared to traditional trucks, where aerodynamic drag accounts for as much as 50 to 60% of energy consumption at high speeds. By refining the cab design, replacing side mirrors with integrated camera systems, and smoothing out the body lines, Tesla has significantly reduced air resistance. As a result, the Semi delivers noticeably better energy efficiency over long distances, especially when fully loaded. A closer analysis shows that this 7% gain can translate into hundreds of additional miles of range per charge, or substantially lower operating costs for cross-country routes. In the context of fluctuating electricity prices, this becomes a strategic advantage, helping the Semi compete with diesel, where fuel alone can account for 30 to 40% of a truck's total operating cost. The most standout highlight is its drag coefficient of just 0.4, compared to conventional diesel trucks, which typically range from 0.6 to 0.8. The Semi's 0.4 is comparable to many high-end passenger cars. This figure, validated through wind tunnel testing and real-world trials, shows that the Semi's aerodynamic design has reached an unprecedented level in the heavy-duty truck segment. From a performance standpoint, a lower drag coefficient directly reduces air resistance, lowering the power required and improving overall efficiency. For operators, this means less wasted energy, more consistent range, and reduced maintenance costs due to lower aerodynamic stress. Additionally, Dan Priestley confirmed that the Semi does not require special or custom tires. Standard off-the-shelf tires, widely available on the market, are fully compatible. This is a major advantage, as heavy-duty truck tires are typically expensive and can take a long time to replace if they need to be specially ordered. With the Semi, operators can source tires from any supplier like Michelin or Goodyear, reducing maintenance costs and improving availability. From a practical standpoint, this helps minimize downtime and makes the Semi more accessible to smaller, independent repair shops, not just authorized service centers, like Tesla's passenger vehicles. The Semi is equipped with an advanced regenerative braking system, and it's extremely impressive. When braking, the electric motors convert kinetic energy back into electricity and store it in the battery, instead of wasting it as heat like traditional friction brakes. In terms of efficiency, regenerative braking can recover up to 70 to 80% of energy in urban driving or on hilly terrain, playing a crucial role in extending range and reducing wear on mechanical brakes. For heavy-duty trucks, where frequent braking is necessary due to large loads. This feature not only saves energy, but also significantly extends brake life, lowering long-term maintenance costs.
So we have two axles. We have the torque axle on the front, and that's geared for acceleration, for hill climb, those big power maneuvers. And then we have a separate axle that is geared for efficiency.
Dan Priestley also pointed out something pretty interesting. Unlike traditional diesel trucks that rely on complex multi-speed transmissions to balance high torque at low speeds with efficiency at higher speeds, the Tesla Semi doesn't use a multi-gear gearbox at all. Instead, it uses two separate rear axles, each designed for a different job. The front axle. Basically, the torque axle is built for strong acceleration and climbing hills. Once the truck reaches highway speeds, that axle automatically disconnects internally to eliminate mechanical drag. Then the separate efficiency axle takes over completely for cruising on the highway. By disconnecting the torque axle, the Semi cuts down mechanical energy losses, helping it use only about 1.7 kilowatt-hours per mile, even when fully loaded. On top of that, each axle gets to operate in its own sweet spot. The torque axle focuses on raw power, while the efficiency axle is all about saving energy. The result is a real-world range of around 325 to 500 miles, depending on the version. This approach cleverly solves one of the core challenges of electric trucks, the trade-off between having enough low-speed torque to haul heavy loads uphill and maintaining efficiency at high speeds for long highway trips. As for steering, the Tesla Semi completely ditches traditional hydraulic assist and switches to a fully electric power steering system. That's a big upgrade, since hydraulic systems need regular maintenance, can leak fluid, and waste energy. With electric assist, the Semi delivers more precise, smoother steering feel and integrates much more easily with advanced driver assistance features. The key thing is, this isn't a pure steer-by-wire system with no mechanical link between the steering wheel and the wheels. It still keeps a physical connection to maximize safety, which is a smart call in the heavy-duty truck segment, where reliability is absolutely critical. From a technical standpoint, switching to electric assist helps cut overall weight, contributing to that earlier 1,000-pound reduction, while also improving energy efficiency and simplifying maintenance. What's especially interesting is that the Semi uses steering actuators derived from the Cybertruck, but they've been seriously beefed up to handle loads of up to 82,000 pounds. The Cybertruck is already known for its advanced electric steering system, and adapting that tech for the Semi shows Tesla's strategy of sharing components across different vehicle lines. These actuators deliver high torque, quick response, and strong load-bearing capability, keeping the truck stable even when it's fully loaded or driving on slippery roads. Real-world testing suggests the new steering system makes the Semi noticeably easier to handle than traditional diesel trucks, reducing driver fatigue and improving precision when cornering or avoiding obstacles. Next up is the electrical architecture, which has clearly been upgraded on the Semi. About 2 years ago, when Jay Leno tested the Tesla Semi, it was still running on a traditional 12-volt system. So moving to a 48-volt architecture in the newer version really changes the game. A 48-volt system allows for more efficient power delivery, reducing losses in the wiring and supporting high-power components like steering actuators, the cabin infotainment system, and safety sensors. And it doesn't stop there. 48 volts also improves overall energy efficiency, makes it easier to integrate with a large battery pack, and gets the truck ready for future automation features. It also contributes to that high 95% uptime, since the electrical system is less prone to failures, while reducing wiring weight, directly supporting both aerodynamic goals and overall weight reduction.
The battery is designed to last 1 million miles.
Right.
You will see some degradation over time,
Right.
but we see that it can last in its original duty cycle 1 million miles.
About 2 years ago, Tesla was using LFP batteries in the Semi, a choice aimed at lowering production costs and improving safety for an electric truck. While LFP batteries have some clear advantages, they also come with trade-offs that matter over the long run. You know, LFP stands out for its excellent safety and stable performance in cold weather. That's a big deal for electric trucks, especially in colder regions where traditional batteries can lose efficiency and degrade faster in low temperatures. LFP cells are thermally stable and much less likely to catch fire or explode, which is critical for a large vehicle like the Tesla Semi. They're also cheaper to produce compared to chemistries like NCA or NCM, but the biggest downside is their relatively low energy density. In practical terms, that means to deliver something like a 500-mile range, Tesla has to pack in more individual cells, so a 900 kWh battery pack ends up needing a higher cell count, which increases the truck's overall weight. Okay. That's why Dan Priestley confirmed that the refreshed Semi versions are moving to 4680 cells. These have nearly double the energy density of LFP, meaning Tesla can use fewer cells per pack while still achieving the same total energy capacity. This also helps bring down the overall weight of the tractor unit. The 4680 cells use a tabless design, meaning they eliminate traditional connection tabs, which reduces energy loss and heat buildup during operation, ultimately improving both efficiency and battery lifespan. The Semi's 4680 batteries are optimized to handle the intense charge and discharge cycles of heavy-duty trucking, including the kind of energy recovery you get from regenerative braking we talked about earlier. The biggest highlight, though, is the target lifespan up to 1 million miles, something that's basically unheard of in the industry. Yeah, put that into perspective. 1 million miles translates to over 10 years of continuous use, assuming around 100,000 miles per year for an independent trucker. That's huge. Not just because it avoids the massive cost of battery replacement, but also because it gives owner-operators much more predictable long-term value, making it easier to plan profits and even secure financing from banks. On top of that, 4680 cells are now significantly cheaper to produce than they used to be, with Tesla reportedly cutting battery production costs by as much as 40%. They're also more reusable thanks to their longer lifespan and ability to handle harsh conditions while maintaining relatively stable performance, which is exactly why Tesla is also using them in the Cybertruck. Two Tesla executives also said the Semi now comes with an advanced driver assistance system, allowing it to automatically stay in its lane, maintain a safe following distance, and even step in with emergency braking if it detects a potential collision. Looking deeper, these features don't just reduce driver fatigue, especially for drivers who are behind the wheel for hours at a time. They also help lower overall accident rates on highways. Data from test fleets shows Tesla's safety systems allow the Semi to operate with minimal driver intervention, while still staying fully compliant with mandatory rest time regulations. The driver's seat is also purpose-built, with memory positioning, power recline, and an auto-retracting seatbelt to improve protection in the event of a crash. Even though heavy trucks aren't always required to have airbags like passenger cars, Tesla goes further by optimizing the cabin structure to absorb impact energy, protecting both the driver and the cargo. Another really promising area is wireless charging, which Tesla is actively developing for the Semi. According to Dan Priestley, in the near future, drivers could simply drive over a charging pad and the system would automatically start charging. No need to plug anything in. This tech, being developed alongside Tesla's Cybercab, uses conductive or inductive methods to efficiently transfer power to the Semi's large battery pack. From a practical standpoint, wireless charging could be a game changer for fleet operations. Less downtime at charging stations. No need for drivers to get out and plug in, especially in bad weather, and it's perfect for fixed routes like warehouse to distribution center runs. For independent truckers, it means more convenience and tighter scheduling without worrying about complex charging infrastructure. That said, there are still technical challenges to solve, like energy transfer efficiency, which could reach around 90 to 95% compared to wired charging, and the upfront installation costs. But if Tesla pulls it off, wireless charging could significantly accelerate the shift from diesel to electric trucks, especially in urban areas and ports where trucks make frequent stops. When it comes to real-world operating data, even though the Tesla Semi fleet is still relatively small, just a few hundred trucks, it has already racked up over 13.5 million miles. That's a big enough number to move beyond the testing phase and into proving real-world viability. What's interesting isn't just the total mileage, but how it's distributed. On average, each truck is logging tens of thousands of miles per year, which shows consistent, high utilization. This creates a valuable data foundation that allows Tesla to continuously optimize both software and hardware through over-the-air updates, basically creating a feedback loop of constant improvement that traditional vehicles just can't match. An even more compelling example is the lead truck in the fleet, which has already hit 440,000 miles on the odometer. That's not just a symbolic milestone, it directly reflects the durability of the electric drivetrain and battery system. When you compare that to diesel trucks, which typically require major overhauls somewhere between 300,000 and 500,000 miles, the Semi is showing real potential for a longer service life thanks to its simpler mechanical design, fewer moving parts, and fewer wear points overall. In other words, the advantage of electric trucks isn't just about energy costs, it's also about superior mechanical longevity. Operational performance backs this up even more. The fleet is reporting around 95% uptime, significantly higher than the typical 80 to 85% you see with diesel trucks, and that's not a small gap. It translates directly into economic value. Every extra percentage point of uptime means more deliveries, higher revenue, and fewer disruptions. The main reason comes down to minimal maintenance requirements, no oil changes, no complex fuel systems, no internal combustion engine tuning, so both downtime and maintenance costs are dramatically reduced. Finally, operational efficiency really shows up in how issues are handled. About 75 to 80% of breakdowns are fixed, and the truck is back on the road in under 24 hours. That's not just a service win. It's the result of a fully integrated digital ecosystem, from remote diagnostics and over-the-air updates to parts logistics. From a business standpoint, that kind of fast turnaround massively reduces losses, since every day a truck is down can mean thousands of dollars in missed revenue. Even though it took nearly a decade from the first concept reveal, looking at the real-world performance and engineering achievements of the Tesla Semi today, it's fair to say the wait has been worth it. This is no longer just a tech experiment. It's quietly but decisively redefining the standards of long-haul trucking. From its smart dual-axle drivetrain, ultra-low drag coefficient, durable 4680 batteries targeting a 1 million mile lifespan, and 95% uptime, to real accessibility for independent truckers. It all paints a picture of a future where electric trucks aren't just cleaner, but also cheaper to run, more reliable, and even more enjoyable than traditional diesel rigs. Jay Leno even called the Tesla Semi one of the biggest leaps in transportation since trucks replaced trains. He described driving it as basically like driving a regular Tesla car, super easy and genuinely fun, with instant torque and strong acceleration without any gear shifting. He was also impressed by the tight turning radius, optimized aerodynamics, spacious cabin with great visibility, and the center driving position, which he said feels surprisingly natural. What stood out most to him, though, was the significantly lower operating cost, the 1.2 megawatt fast charging capability, and the battery's potential 1 million mile lifespan. In his view, the Tesla Semi could realistically replace diesel trucks in the near future. So here's the big question: when a truck can run hundreds of thousands of miles with lower operating costs, longer lifespan, and better safety for everyone on the road, does the global logistics industry really have any reason left to say no?